Are updated. Looks like titles are updating. That looks good. All right, I do not see this live yet. Okay, that looks like that's live. Just going to take a few minutes and get things set up here. I have to copy those. Okay, let me go ahead and copy the link over here. Gonna let some people know that I'm streaming now. I'm going to try to get out of some of these extra tabs. So I am cutting back on the tabs. Hardcore cutting back on the tabs. I have 3 windows open at this exact moment. Browser windows, other than this one that I'm using for streaming. So we are cutting back on the tabs. Last time I was this early to your stream, my life was still good. What? What's happening, Elon? Uh-oh. Okay, chat's coming up. All right, chat is up. And I think there was 1 or 2 other things that I needed to copy and paste here. Oh, yeah. All right. So I'm going to do a little Twitter tweet. Oh, no. What happened? What happened to the... Oh. Didn't copy the little red madoodle. Live now. Boop, boop, boop. Little posty McPosty over there. Gonna do a little posty McPosty over here. Where was I at with this? I'm a posting. Oh, here we go in the live streams. All right, let's see who else. Who else might we want to tag in this? There's a few people I know that were interested. Is Ulysses in here? Nope. Is Josh in here? Yep, Josh is there. Who else? There was Devin. I don't know where. Let's see if Devin wants to join in. Where's he at? I don't actually know what his Discord name is. Oh, okay. Yeah, his Discord's name. Damn it. All right, we're about to get started, folks. We're not going to have any music on this one because, again, this is some educational style content that I'm doing, and so no music. All right, copy link address. Yes. Hey, everybody, how's it going? Tuning in, cool. All right, let's go ahead and get this thing started. Let's go. Well, hello, and welcome back to those of you that are joining in again. This is part 2 in our Proxmox series that I'm doing here. I'm probably going to do one a week-ish. Might do more than that, depends on how things go. I am in the pipeline to become a Proxmox authorized reseller and certified trainer. So fingers crossed in the next 30 days, both of those will happen. So we'll see how that goes. And anyway, one point of making that is if you do decide to get a Proxmox license for your business and what we're doing here helps, I would appreciate being your point of contact for that. So feel free to reach out. Anyway, last time we just set up a single node and we just went through the install process and some of the things that we need to talk about for the install process, some of the decisions we need to make. I want to keep this decision focused. Feel free to ask questions at any time, by the way. Today, we're going to go over the decision process for setting up a cluster. And we're going to approach this from the perspective of a small business, because my interest in helping people is primarily in achieving greater profitability. So I'm going to bring up, I'll paste in the chat some notes here. Let's go ahead and do that. Boom. If you want to see the notes I'm working from. So the first thing I want to talk about is high availability, because I think the number one reason to cluster is to get some number of nines. So here's the high availability page. And it gives a breakdown. What does 99% uptime mean? It means that your downtime is 3.5 days per year. What does 99.9 mean? 8.76 hours. If you're running on a single node, I would suspect that over the course of a year, you're between these two numbers. You're between 99.9 and 99.99. Now, it's very possible that, set it and forget it. You could have 100% uptime during a year. That's not impossible. But with a single node, I would imagine that you're going to be between these two numbers. When you enter into a cluster, then you start to get between these two numbers, where your downtime per year is between 5.5 minutes and 30 seconds. Or even 3.5 seconds. So somewhere in this range. Actually, I think the cluster kind of, depending on how you count downtime, because there are, for example, a VM might be paused during a migration for 500 milliseconds, for example. I wouldn't necessarily call that downtime. That's just latency. Anyway, if you want to be at this number of nines or above, you're going to have to do it in your services and software. It's not going to be something that a cluster can solve for you, because there's going to be certain issues that are going to arise that you're going to have a few seconds of downtime throughout the year. Okay. So with that said, when we're focused on a 2-node cluster, we can get in this range. If we go to a 3-node cluster, then maybe, then we're closer to this range. That said, that's one of the reasons for a cluster is because you get high availability. You can do migrations, have automatic failover, not have to manually intervene. That's why we're talking about clusters. So last time, let me go ahead and log in here. Last time, I created a Proxmox instance, and it was virtualized. This one's actually real. This one is already set up, and I have another one here that I've installed. It was the same process. So I'll go ahead and log into this one as well. So now I have these two instances, but what you'll see is that they don't know about each other. They're not able to share resources. They're not able to create high availability groups. They're isolated instances. Before we create a cluster, there's a few important things that you need to know. One is that whatever you want your node names to be, you ought to finalize it. So I'm just going to stick with the node names that I have. This one's called MPLX2. That stands for Optiplex Micro 2 or Micro Optiplex 2. And this one's called Micro PVE because I didn't think to call it MPLEX 1. But I'm going to leave that alone because I already have a Plex instance running on this. And if I try to rename this, then it's going to mess that up and I'm going to have to redo it. Renaming things is not something that you do once you start a cluster. Also, my IP address needs to be finalized before I join a cluster. The IP address I could change while I have instances running on a node. But once you get into a cluster, if you try to change your IP address, then the node is going to go down and that could have cascading effects. It could be bad. So that's something that we need to do beforehand. And I'm actually going to do that because this one has the IP address that I want. It's called 32. This one is at 157. I don't want that. I want this to be 31. So I'm going to show you how to change the IP address on the node and then restart the services. So we'll go ahead and do that first. I'm not going to go through how to change the name. It is possible to change the name, but it is a very error-prone process. I don't recommend it. If you've already got things running, if you want to change the name, you're going to move everything over and then reinstall. All right. So let me go ahead and bring over my terminal window. And I'm going to go ahead and SSH into, this is the first node that I set up. So now I'm logged in here and I'm going to change the IP address by going to Etsy Network Interfaces. And this is the file and the directory, this directory right here, Etsy Network Interfaces.d, that this is sourcing from. And this file, Etsy Network Interfaces, this is where Proxmox is changing files when you do anything with networking in the user interface, in the web admin. So here, I'm going to change this from 157 to 31. And I also may need to change in the hosts file. So I'm going to go to hosts here. And we see here, this is actually quite important. This has a real IP address. This is important for the way the cluster works. So I have to update the host file. And if I wanted to change an IP address, I have to do that on every system. Let me actually go back real quick. I want to see, I don't think I can change the IP address from the webmin, but I'm going to try anyway. So let me go back here. We'll go to hardware. No, we need to be at the node layer. We're going to go to network and I'm going to see if we can edit it right here. Okay, we can. So this would be the way to edit it. Don't edit the files directly if you can avoid it, because there's a few different places that need to be edited. This software is going to run a process to update that. So we're going to change it here. And then I'm going to go ahead and hit OK. And then apply configuration. So once I apply the configuration, this service is going to go down. But we're going to let it do that. And it's important to use static IP addresses, not use DHCP, because of the way that the cluster works. DHCP is going to be more troublesome. You can use DNS with DHCP, but then you have to do some manual processes. So we won't worry about that. And this is never going to come back up because the IP address has been changed. I expect it'll take maybe 5 to 30 seconds, something in that range. So now it should already be back up, and it is. All right. Oops. Okay. So the next thing we're going to do is we're going to go into our data center layer and we're going to create a cluster. And when you create cluster, it's going to pop up and ask you for a name. And I'm going to call it Cluster Muster. And we are going to, this is something that we'll come back around to later. We're focused on a 2-node cluster right now. So what we're going to have is we've got 2 Dell Optiplex Micros. They're going to be in a rack mount 1U. I can show you what that looks like in just a second here. Let me do Dell Optiplex Micro rack mount. So there's two relatively nice options. The first one is from RackNex. I'll drop a link to that. So if you take a look at this, obviously your system may be different, but if you take a look at this, it's a very clean 1U install. And there's some room. What we're going to need is a Raspberry Pi and a network switch to actually build this out as something that we can go put in a data center. So we need a Raspberry Pi and a network switch and also a power switch. So we'd probably put the power bus on the back of one of these straps, maybe strap the Pi on top of here, the network switch on top of here, get it all connected. So this one is about $200. So it's 184 euro. It's 10% more in dollars. So about that much. And then the other one that's really nice is if you go to, there's one of the 3D print sites, Printables. Here we go. I think this is the one. Yeah, this is, I don't know if this is the exact one I was looking at. No, this is not. There's another one. So if we did Dell Optiplex, just kind of give you an idea what this would look like. Micro rack. There we go, rack. I don't know where it went. Was it this one? Nope. Okay, well, I'm not going to worry about that right now. I'll come back around later and find a link to it. But this is a production system, is what I'm saying. We can actually mount this. So when we create the cluster, we're going to use our primary network address. I'll actually show you how to update this the hard way later. If we're going to create a cluster from scratch and have it all planned out and do everything that we need to do, we'd actually already have an instance that acts as the firewall / router. We'd have a VLAN with multiple addresses. We'll get to that. But for right now, we're just going to put everything over a small network for our little cluster. So it's okay that we only have VMBR 0, and that's what we're using for this. What this is defining is what CoroSync, which is the cluster sync, what CoroSync is going to use as the network address. Typically, you want to have multiple network addresses or network cards, and CoroSync would go over a 1 gig connection. Even it would be fine even if it was a 100 megabit connection, but you don't have to worry about that because nothing has only 100 megabit anymore. But the main thing is that you actually want it to be isolated from other network traffic. And it has to be low latency and quick. It should have a dedicated card. It's okay to just run it over a VLAN when we're talking about 2 or 3 nodes. So we'll go ahead and create this. I will pop that in there, by the way. Okay, so it says task OK, which means that it has created a cluster. So we're now in a cluster of 1. And I'm probably going to have to refresh this or something. Let's see. Can we get back to cluster information? No clusters defined. That's not good. So create cluster ran. Where is our join information? Okay, let's... Huh. I'm going to try this again and just see what happens. Okay. All right. So I don't know why I had to click it twice. I did. That's fine. When you click on join information, this is JSON encoded data. So I actually want you to see what this looks like. So this is saying, hey, here's my IP address. In this case, it's actually wrong, which is interesting. You know, I think we ought to go ahead and give this thing a reboot before we go any further after changing the IP address. So I'm going to go ahead and do, whoops, 131 here. Whoops, not 31, 131. So we're going to go ahead and do system control reboot. And this won't take long, maybe 2 minutes or so. Yeah, like I said, IP address changes are one of those things where it touches multiple parts of the system and you want to have that done before you create the cluster. I'm hoping that restarting this doesn't put the cluster into a bad state itself. So this is going to do what it needs to do for a couple minutes. I'll also try to log in via SSH to see if we have a problem here. All right, cool. So SSH came back up. So if I refresh this now, this should be back up as well. And then, okay. Now let's get the join information. All right, so somewhere it still has the wrong IP address. Before we continue, I want to make sure that that is fixed because that could come back to haunt us. So let me go ahead and do this. Whoops. Oh, we don't have RG. That's okay. We'll use grep. grep-r. Okay, so what is this coming back with? Known hosts. We do need to edit the known hosts file, believe it or leave it. So let's change that to 31. And we do need to change Etsy issue and Etsy hosts. Okay, so I think I see what happened here. The UI is only... the UI actually doesn't have the hooks in place to edit these other files. So I was actually right to manually edit Etsy hosts. All right. With that out of the way, now I think if we click on join information, it'll come up with the right stuff. Nope, still not. All right. Can we get rid of this cluster? No, we cannot. So we actually may have to edit this. Like I said, this right here is base64 encoded JSON. So if we were to open up a browser tab, like I'm doing here, we can paste this in. And there are other tools to do this. I'm just doing this so you can see it. This is not something you need to do. I just want to show you. So ASCII to binary. There we go. And then I will add a JSON parse on this, json.parse, so that we can take a look at it and see what it shows. All right. So this data shares the IP address, the fingerprint, some information about the cluster and the interfaces that are already set up. So basically, this configuration shows information that already exists about the cluster so that the cluster files can be created correctly on the machine that we're passing it to. Now, since this is wrong, we may not be able to use it. Like I said, before creating the cluster, should have made sure that everything was right with the IP address. So this is what we're going to do. I'm going to check one more time. Is there anything else that has that IP address in here? Ah, members. Okay, so where is that coming from? That is coming from... I don't know where that's coming from. I don't know why it thinks that any of the members have that IP address. But I know that there's also... I'll clean this up for later. I know that there's also some stuff in varlib. So let's try looking there as well. Oops. Varlib. And there's one other place where this might exist, which I don't want to have to deal with if it's there, but... Yep, that's what I thought. It's this file right here. So there's a SQLite file. So this is a database. We can run .schema on it. Again, we'll do this the right way next time and make sure that the IP address is set before we click create cluster. But if we look for select, what is it? inode, parent, it's hard to read through here, mtime, type, name, from tree. I'm imagining this is where we're going to see that IP address showing up. I don't see it showing up here. 253. Nope, I don't see it. I don't see it showing up here. So I'm a little confused as to... All right, let's do select star. .192. Oops. 253.157. Do we have that in this data? Okay, I'm going to clear this out. And I'm going to run this search again. Let's see what we get. Again, this is not typically something that you should have to deal with. 253.157. All right, I don't see it in there. So that looks good to me. All right, I'm going to try refreshing this one more time. And we're just going to go with it. Yeah. Okay, so we're just going to go with it. So I'm going to copy join information. So back on track. We're going to copy join information. We're going to go back over here to the second node in the cluster that's going to join. We're going to go to its data center area. We're going to click on cluster in its data center area, and we're going to do join cluster. So we're doing assisted join, except I'm going to uncheck that. So I do assisted join so I can paste in the information. It copies it all out, and then we're going to change this to be 31. That's the actual peer address. Now this one is going to be 32. Now, we have to do this by password at this time. The nodes in the cluster should all have the same password, and they will have SSH password enabled by root will have password enabled. So like I said before, it's very important that you choose a long password when you're setting up the root password, because you do actually have remote access through that. So just one moment here. All right, authentication failure. I probably typed it wrong. Oh, dope. Gotta change that to 31. Okay. Okay, cool. So now they're getting set up. So I should have given the overview before, but some of the decisions we're going to have to make here, if we're doing a 2-node cluster, we have to have a third node that's a quorum node. You can't do a 2-node cluster because then you don't actually get the benefits of the cluster. So we're going to set up a quorum device, which in my case is just a Raspberry Pi that's running Debian as well. It's the same Debian that these are running. So that gives us, and it doesn't have to be a Raspberry Pi. It could be anything. It could be anything. I recommend it be running Debian, not Ubuntu, not Mint, but it actually be running Debian, although many of those others will work. But when we're talking about a production setup, we're administering fundamentally a Debian system. Proxmox does not have a lot of tweaks from the base Debian system. It is a Debian server. So in terms of simplicity of administration, we don't want to have Ubuntu on one device where the network file is different. We want to have Debian on all devices so that all of the administration, all the commands we run, everything that we're doing is the same. Okay. Let's see if... Okay, cool. So as you can see here, now the data center recognizes both nodes in the cluster. It looks like it regenerated the certificate, perhaps, for the SSH. And that's why it couldn't connect. When you join the cluster, it does regenerate certificates so that they all have the same certificates and they share them together. All right. So now we've got these together, but we need a third node to act as the tiebreaker so that we can have a quorum. So for that, like I said, I've already got the Raspberry Pi set up, so I'm going to SSH into that. And that one, I've already set its IP address to be 30, 0, because it's the tiebreaker. So I've already set this one's host name and set its IP address to what I want it to be. I'm not sure if it's static or if I just set it in my router. I think I actually set it in my router. Let me look in here. All right, network interfaces. Did we set this statically? Oh yeah. So ETH0. Okay, so it is using DHCP. For this one, that's okay because this one is not part of the cluster. It's not a Proxmox node in the cluster. It's just a voting node in the cluster. So it's okay that its IP address isn't static and in Etsy hosts and all of that stuff. I'd like to put it there, but I have it statically assigned on my router, which is why it's set up that way. So from here, we're just going to run a couple of commands, and I've got these in the documentation that I'm working from right now. So I'll go ahead and give you a link to that. But assuming the base system is set up, all we need to do is, well, actually, there's a couple of things that we need to do. First of all, let me go back to the nodes that are in the cluster. You'll notice that from either node, I can manage either node. So see the IP address changes, 32 over here, 31 over here, but I can manage either node from either node. So I can be on the IP address that has 31 and managing the one that has the IP address of 32. So I'm going to go into the shell on this one, and I'm going to put in apt get install -y corosync qnetd and hit enter. And it's generating a key, doing some stuff, and it looks like it's done now. And then I'm going to go to this node and I'm going to do the same thing. Apt get install -y corosync qnetd. So every node in the cluster needs to have that installed. That needs to be part of the base for all of them. So now on the node that is not a Proxmox node, but just voting in the cluster, now we're going to go back here and we're going to install not that, which is a little confusing. Oh, whoops. Whoops. Whoopsie. I already made the first whoopsie. Okay, so I said that's a little confusing. Yes, it is. So we're going to uninstall qnetd because qnetd goes on the voting node. On these, we're installing qdevice, corosync qdevice. So there we go. Okay, so now we installed corosync qdevice. So to remove, I did apt-get remove -y -purge. It's going to purge any of the configuration files or save data as well. All right, qdevice. There we go. So now those are set up. Okay, now I'm over here on the Raspberry Pi, and I'm going to run apt-get install -y qnetd. So the reason it's confusing is the qdevice is where you install the Quorum Network daemon, qnetd. And the nodes that are using it, let's see, apt-get update. Oh, whoops, I didn't do corosync qnetd. That was my problem. Corosync qnetd. And the ones that are using it, you're installing the client, the qdevice client. It's also a daemon that continually runs, but it's interacting with these. So that's why we have that problem. Also, we're going to need to copy the authorized keys file over to this device. So I'm going, I'm going back to the nodes, and it doesn't matter which one I pick because now that they're in a cluster, there's a number of things that, let me go ahead and show you, are actually, they're now symlinks. So if we look in SSH, you can see that authorized keys is actually a symlink to Etsy PVE priv authorized keys. But we're going to go ahead and take this, boop, and we're going to grab all the authorized keys, or do we just need the ones that are for the... In this case, I have mine for me logging in as well. So you can see there's my laptop and my desktop. So this one right here, root at mplex2, that's one of the authorized keys we need. So I'm going to bring that over. And let's see if authorized keys exist. It does. So then I'm going to put down here Proxmox nodes. And, whoops, not what I wanted. I didn't actually copy this. Let me copy and paste. We can do this with password as well, but I'd rather not. And so then there's this here. This one's going to come over as well. So I'm going to go ahead and paste that one in as well. I don't want to enable root password via SSH for this device. So it's going to get set up with authorized keys anyway. In the documentation, it will tell you to set the password. If you copy over the authorized keys, you don't need to set the password. And then it will continually add authorized keys as the cluster grows. So you don't have to worry about that again in the future. All right, so now that we've set up CoroSync device on each node in the cluster, CoroSync QNetD on the voting device, the last step is to run... Whoops. Let me go back here. So I'm going to, in this shell, let me see, will it control K? No, it won't, but it will clear. We're going to run PVE CM Q device setup, and then the IP address of that device, 192.168. And if we had this established in the host file, we could use the host name as well, 253.30. So PVCM is cluster manager, CM, cluster manager. Q device is a subcommand, setup is a subcommand, and then the IP address is arbitrary data that we're passing in based on our network. So go ahead and do that. Are you sure we want to continue? Yes. And you'll see that it was running copy ID. Oh. I wonder why it's asking for the password. It should have just worked. Let's see. Did we... Oh, whoops. I see what happened here. I see what happened here. So I didn't actually copy... Let me go back. I'm going to go into the shell over on this one. Oops. So I didn't actually copy... I just selected. I've gotten used to selection in my terminal doing copying, but that doesn't work in the web page, of course. So I had just put the same thing twice instead of putting it in once. Okay. All right, there we go. So now I'm going to actually cancel that process because I'm not setting this up with a password. So I'm going to go back. It's asking me for the password. I'm going to Control-C to cancel that. I'm going to run the same process again. Now this time it should just go through. Yep, see, didn't ask me for the password. Okay. Oh. All right, I think that we're missing a step here. Let me try this. We're going to do system control enable CoroSync QNetD. Whoops, QNetD. Let's not do typo. and then start QNetD. I think I forgot those steps. All right, we'll run this again. Okay. All right. Coro sync device. All right, let's try this on these nodes as well. So let's try. Need to bring up the actual documentation here, because this is not going the way that I planned. Okay, apt install CoroSync Q device. Let's just make sure this is up to date here. Apt get install -y CoroSync Q device. Already installed. Okay, that's what's expected. Let's go back here. Apt get install -y CoroSync Q device. Already installed. I've done this. I have it working in another instance. Let's go ahead and uninstall and reinstall. And let's do it from the one where the IP address hasn't changed recently. All right. And over here, same thing. Let's remove. No Q device configured. Okay. So let's go back up. Q device setup. Let's make sure system CTL CoroSync Q device. I'm going to enable that. Okay. Start. All right. Journal control Zifu CoroSync Q device. Okay. Well, that's not how this was supposed to go. I did not have any trouble the first time that I ran through it. I don't have anything additional in my notes here about that. Okay. So let's go back here and let's try this again. I might do what it tells me to do. All right, PVCM-Q device setup 192.168.253.30. The reason that I wasn't following the instructions that it gave in the output okay. All right, let's try PVECM status. Let's see what we got. Okay, we got total votes of 3. So that means the Q device vote was not set up. So we do need to remove the Q device. Or we need to do a force on this. So let's try just adding a force flag. Setup address options come afterwards. That makes sense. Okay. So we'll try doing a force after this. Failed. 157. Okay, there's our problem. All right, so somewhere the cluster still thinks that this IP address is the regular IP address. So here's what I'm going to do. We're going to go into fixing a cluster problem right off the bat. And this is the first instance I set up. This is the one that's having the problem. I am going to go into etc PVE. This is a special mounted file system. So if I type mount and we take a look at the file systems and we look for PVE, you'll see that Etsy PVE is a fuse type file system, and this is being mounted by the service PXCFS, which is Proxmox cluster, or PXFS. Come on. Is it PC? PX? Nope. Okay, I can't remember. Maybe it's PF. I can't remember what it is right now, but it's user sbin. Let's see. It's one of these that starts with P, or unless it starts with F. Where is it? Where is it? User sbin. PSAUX grep FS. PMXCFS. There we go. This is the process that's mounting that file system. So this file system is actually an application. It's not a file system. So it has certain rules that work differently than what you're used to. You cannot edit the CoroSync file directly. And you must edit the CoroSync file that is in this directory. Never edit the local CoroSync file. So we're going to call this one, I always like to put a timestamp whenever I'm doing a dot back. So we'll call this one 2025-03-15.back. And then we're going to edit this file, and all I'm going to do is bump the version number of this to cause everything to resync and get updated, because of that IP address change that happened midstream. You can see the IP address is correct in here, but when this gets updated, it triggers some other updates throughout the system. So here we have version 2. Oh no, this is different. Config version 2. We're going to change this to config version 3. That's the only change we're going to make. Everything else is going to stay the same. Not version, but config version. So we're going to exit out of that. And then the way that this has to work is we're going to create, well, I guess I shouldn't have called that back and then not, I edited it, so that defeats the purpose of calling it back. But we're going to overwrite the existing file with the new file. And what that's going to cause to happen is that there is, actually before I do this, I'm going to quit out of that. So there is a local CoroSync file, corosync.conf. You can see that this is version number 2. And if I go in to the other node and I do cat etsy corosync.conf, you can see this is config version 2. Sorry, I said version 2 over here? I meant config version 2. So when I move this file in the networked file system, which is where I must move it, we cannot edit this file directly. It must be copied and then moved. That is the acceptable set of operations because, again, it's not really a file system. It's an application that's masquerading as a file system. Once I move this over top of here, what will happen is that it's going to propagate changes to the local file system of the other nodes. So now etsy corosync.conf, you can see that that got version 3. And if we check our local version here, you can see now it's got config version 3. So that's the way to edit that file. Never, ever, ever, ever edit the CoroSync config file that is local, because that file is read before the cluster creates its quorum, and editing that file on a single machine can take down the entire cluster because it won't sync to the other machines, and then they will fail themselves because they are out of date. So they will propagate what the highest version is, and all of them will fail except for the one that has the locally changed version. So don't do that. All right. So with that out of the way, hopefully now we're going to be able to run this again and have it work. So QDevice setup force. Copy the certificate to all nodes. And I just do not know where that IP address. I'm going to search real quick. Proxmox change node IP address. I have one other thought as to where it might be. So I'm going to go into Etsy hosts here. Okay, that's correct. I'm not sure if Etsy hosts is directly controlled by CoroSync. It looks like it's not. Okay. So I have a suspicion that the place where it changed was the Etsy hosts on the other machine in the system. Nope, it's not there. Although this is kind of confusing because normally we would see this in both of these. So I'm wondering where that's coming from. Another thought is that it could be coming from the network itself, but I'm going to go ahead and just add this in here, MPLX2. So this turned out to be a bad tutorial video. Lots of oopsies. Lots of oopsies. All right. All right, and then I'm just going to double check that the IP address is correct in the local CoroSync conf. Yes, it is. Let's check that it's correct in the cluster CoroSync conf. Yes, it is. Now let's check on the other node that it's correct in its CoroSync conf. Yes, it is. Okay, so I'm going to try one other thing, which is just restarting the cluster on both nodes. So we're going to do a kill all of the cluster file system. And then we are going to restart the cluster. So kill all pmx cfs and then system control ctl, that is, start pv-cluster. And then I'm going to do the same thing over here. Let me actually do it on the node that is the node. Okay, so kill all pxm cfs. And then system control start PVE cluster. All right, now let's look if we got Etsy PVE CoroSync, and we do. So, okay, that's back up and running. So I'm just going to try it again. Fingers crossed. All right, cool. Okay, that was good. So the missing step was, because we have a cluster, it's sharing data between nodes on the cluster. When I made the IP address change, which is part of why I said, before you start the cluster, make sure you got the IP address right, and I did one step out of sequence there, it was resyncing the old IP address in memory. So we had to kill the part of the cluster that was syncing things in memory and restart it so that it would go through. Okay, so now if we do PVE-CM status, we see expected votes 3, highest expected 3, total votes 3, quorum is 2. So now we can actually go to work with our cluster. So one of the things that we need to do, I'm going to go ahead and close out this tab because we don't need both tabs open. We only need to manage it from one. What I'm going to do is, on the second one that I set up, I have another disk. So there's the disk that I installed the operating system on, and this is how I recommend that you do it. You have a disk for your operating system, you have another disk for other stuff. We're going to go into a couple of really important things here now that we got through the minutia that it would have been nice if we didn't have to go through. By the way, feel free to ask questions at any point. So here I have another drive. I'm going to go ahead and click wipe disk. So this will totally erase any LVM partitions, any old data that was on there before I put it in this machine. It's going to wipe out all the partition data. So, and I've already done it, but I'm going to go ahead and do it again anyway. And there's actually a command called wipefs that is what this is running under the hood, I believe. Are you sure you want to do this? Double check, triple check, make sure, yes, I'm deleting the right one. Yes, we're going to delete it. Boom, boom, wipes it out. And then I'm going to click initialize disk with GPT. So that's giving it a partition table. So initialize the disk with partition table. Great. Okay. So it is best to have your operating system disk be very simple. Just use the defaults, the LVM. It's going to make it easier to debug if you ever have a problem with boot. It gives you a safe space away from shared drives or drives that could fill up with backups or whatever, which we'll get into in a minute. And then you want to have another drive that's either going to be part of your replication or your cluster. So I don't want to do shared drives because we only have 2 nodes. And if I was going to do a shared drive, I'd have to do a shared drive from a cluster so that I know that the shared drive doesn't go down on whatever node it's on and then cause everything else to go down, right? So we're going to do a replication because we only have 2 nodes. And we're going to do that with ZFS because that's the only file system that's supported. So I needed to wipe out this disk and prepare it to be able to put ZFS on it. So we'll get to that in just one second. Question. What are all the files that need to be edited before creating the cluster to have the correct IP and avoid the issues? So it is just 2 files, Etsy network interfaces, and which in the future may be Etsy network interfaces.d/name of interface. That's the way that Debian is doing it currently. It is still correct to use just interfaces, but I imagine the Proxmox software may update to use the .d/ whatever the interface name is, or it may keep it all in one file for the host and just put the files for guests in the .d folder. And then Etsy hosts. Those are the 2 things that need to be edited, but they must be edited before you click create cluster. So I clicked create cluster, then something went wrong. I clicked create cluster again. So it created a cluster. It was only running on the one machine, but the cluster can run on a single machine. It's going to have one vote. It's its own vote, right? We create the cluster on one machine. What I could have done to remedy the problem that I didn't realize is that before I went to join the node on the other cluster, I could have done, once I realized I had the problem, I could have done kill all PMX, PMX stands for Proxmox, CFS, cluster file system, and then restarted the cluster daemon PVE cluster. Syscontrol start PVE cluster. I could have done that. If I had done that, then when the other node joined the cluster, the memory would have been clear because it was only one node at the time and the memory would have been cleared. The problem was I added a second node. And when I added the second node, now the memory between the 2 is shared. So if I want to make a change manually, if I want to fix something manually, that means I either have to shut down all of the nodes, not leave any of them up and running, and then bring them back up. Or I have to, one by one, kill the synchronization service on all the nodes and then bring it back up. It is risky to kill the synchronization service on a node because if the node doesn't sync for too long, like let's say that we had a production cluster, and I would never if you have a production cluster and you want to make a change to the name or the IP address, move everything off of that node and reinstall it. That is the safe thing to do so that you don't, because it's not really a supported process to rename it or change the IP address. You just remove that node from the cluster and then you reinstall it and add it back to the cluster. That's the correct way to do it. And it's probably going to take less time. It's certainly going to take less troubleshooting. There should be no troubleshooting when you do that, other than if you forgot to remove the node from the cluster and you have to remove it from the cluster ex post facto. Anytime you're adding a node to the cluster or changing any of the details of the cluster, it's a really good idea to run PVECM status, because you want to see that the number of votes matches what the number of clusters you have. If you take down a node and then add another node to the cluster, you're actually taking a vote down. So you're skewing the votes. So you want to make sure you do that. Anyway, but yeah, you can kill the cluster synchronization service, because the cluster synchronization service doesn't directly have anything to do with instances that are running. So killing that service is not going to affect a running VM or container. However, it may cause the watchdog to trigger. Well, it will cause the watchdog to trigger eventually. And when it causes the watchdog to trigger, if things are not back up in order, then it's going to just shut everything down on the node. So that's something to be careful of and to be aware of. Now, the watchdog, you have a few minutes before the watchdog triggers. It doesn't trigger within single-digit seconds. But you do want to, if you've got a command to do something with cluster management and it needs to be done on each machine, do it on one machine, wait 10 minutes. Do it on the next machine. Wait 10 minutes. But generally speaking, you don't do these things. It's maybe a happy accident that I had that mistake right now. But generally speaking, you don't do these things. If you decide, oh, I really wish this was named something else, it just doesn't look as cute to me named this way, you drop the node from the cluster and you reinstall it. And because even with this 2-node cluster, because we've got the quorum device, that's okay. We can do that. All right. So with that said, but if you forgot to remove the node from the cluster before you reinstalled it, then you'd have the old node showing up as a negative vote, meaning that it can't vote, so it's voting offline by default. Then if one other node goes offline, then the cluster is no longer quorate, because now you have a deadlock again between the dead node and the node that's rebooting, and then the quorum device and the node that's online. All right. So, like I was saying, we're going to go into disks and we're going to create replication. So let me go back to where I was. So this is the one that I set up secondarily. So I'm going to go to ZFS. I'm going to do create ZFS, and we're going to give this name of, I think we're supposed to call it tank 1. I think that's how we do it. RAID level is a single disk, because we're going to do replication on the network. Compression is on a shift. That shouldn't matter. Order doesn't matter. Okay, this is good. We're going to click create. So you have tanks and then you have pools. So, I may have gotten that wrong. It may have created it as, let's see, create ZFS, name, no one used, yeah, okay, so that, I don't know why it's calling it pool, because they call it tank, but whatever. All right, so now we could create a directory. Oh, can we not create it from, oh, weird. I will have to double check on that. Okay, anyway, so we want to use the whole disk with ZFS because it actually does health checks and things directly on the disk. You don't want to use ZFS through a RAID controller unless it's set to pass-through mode. And if you can avoid it, you don't want to use a RAID controller at all, because the RAID controller does add a little bit of latency. So with all that said, now we've got ZFS set up, which means that we can begin to set up replication, except that we need ZFS set up on the other one. Now, on the other one, I don't actually have a second disk in there yet. So what we're going to do is a little bit of tomfoolery. So we have in here additional partitions that we cannot see yet. Let's see. I actually haven't created those partitions. Because I did this in a weird way, I'm going to have to do something else in a weird way. So I'm going to have to create a partition Can I, let's see how, if it allows me to do this. ZFS storage name, no unused disks. Okay, it may not allow me to do it the way that I'd like to do it. So I might have to wait to get the other disk before I can set this up with replication, which is fine. I will do that. But let me see if I can run this one weird trick first. Let's see. Whoops, not. Let's see, dev SDA. Yeah. So we're going to create here a new partition. Partition size, yeah, that's all the things. We're going to change the type to MBR partition scheme. We might change it to that. Or can we change it to GPT partition scheme? Or Linux partition scheme? Can we change it to ZFS? I'm hoping that we have the ZFS option. Linux users home, Apple FS, Solaris, CephFS. Come on. Do we have to select a type? Okay, let me see. I'm going to just search something real quick. I thought that it would just show up because it was unused. Second. How to install ZFS on a partition. I'm probably going to have to do this by hand. That's not an answer. Okay, I should have looked up how to do this before. But it's easier just to get a second disk. I'll get a second disk. We'll have to continue this part once I get a second disk. But let me see, was there any, I'm going to look one more time. Is there any other one of these? Okay, so let me go back for a second while we're talking about this. So, when we're in high availability mode, we can have local storage and the VMs are local, but they're not going to have a failover mode because they're only going to exist where they exist. So that's not good. We don't want that. The failover mode would be doing a backup and then a restore. And if we have a Proxmox backup server, we actually can use the Proxmox backup server as shared storage, but then if the Proxmox backup server goes down, same problem. So we don't want to use any type of shared storage that's not part of a cluster file system or replication. So the only two options we have are ZFS, which allows us to replicate, which when we have two nodes, we can do that between two nodes. Or we can use CephFS, or we could use another file system that's being emulated on top of a network file system. So ZFS over iSCSI, or NFS over Ceph, so on and so forth. But we can if we're going to use Ceph, we can just use it directly, and then we're going to get better performance and everything anyway. So rather than put something over top of Ceph, we would just use Ceph. If we were using Fiber Channel or iSCSI, then we would want ZFS over one of those, or potentially LVM over one of those. But in a two-node cluster, even with a third device, we can't have a quorum because there's multiple pieces of software, so there's more than one cluster that runs. CoroSync is the management cluster. It's what's syncing the device's other data, and it's at a management layer. Ceph, you can have a Ceph cluster only on, out of all of your machines in your cluster, you could have a Ceph cluster only on 3 of them, and then have 5 of them use those 3. So Ceph does not scale down to 2 nodes, and it's not just about needing a third member to provide a vote, because the vote is with the data. Ceph needs to know this copy of the data doesn't seem right. Let me ask one of the other nodes. Okay, these nodes agree this data is correct. You could technically run Ceph and 2 nodes, but this is far more dangerous because it's not able to do what it's designed to do. It's not designed to run with 2 nodes. That would be a degraded state. And because there are going to be errors that happen, it's designed to be self-healing. So it is error-free via error correction. So you don't want it to be in a state where it's expecting that it's okay if there's a minor failure because it's going to correct itself very shortly. It has to be, any type of failure needs to be corrected immediately. And that's not going to be able to happen in a 2-node setup. So that's why we can't use Ceph. That's why we're going to make the decision. I am curious about directory though. I have to double check on directory. There may be a way to do a shared directory between the two, but that's not in the current documentation. There was a way to do something like that at one point. I believe that is no longer officially supported, or it was never implemented that way because I've seen the document anyway. So that's why we're using ZFS, is because we can get things set up in a way that's actually production ready. So what will happen is that in the event of a catastrophic failure, the replication that is provided by ZFS will be some number of minutes behind, 1 minute, 2 minutes, but it will be a snapshot that is a consistent snapshot just a few minutes behind. So in the case of a catastrophic event, that virtual machine or container will just begin on the other node at the last snapshot, because ZFS is not doing a live write for write sync. It's just doing a snapshot sync on a timer very frequently so that there's very little traffic to go across. And ZFS is very good with snapshots and all those sorts of things. Anyway, so yeah, I don't know what else. Let's see. I'm going to try one more thing. I need to install ZFS on a partition, not a whole disk. What partition type should I select with cfdisk? Let's see what we get. Linux file system. Okay, that kind of makes sense actually. All right, Linux file system. Boom. All right, so we are going to go ahead and write that. Yes, I'm sure I have to type out yes. And then I need to quit. So I'm going to go back over here, and I'm going to finish. I'm going to provide the command line how to do this as well eventually. All right, so create ZFS. Okay, there we go. Boom. So that did work. That's going to work for us. It's not the ideal. I'm going to call this one tank 1 on this device as well. I will get the other disk so we can do it the ideal way, but we're going to do it this way for now. Also, the sizes are not matched at all, so of course that's a problem. All right. So now that I've got both of these set up, and my hope is to actually fail this, and the end result will be to show how high availability works. So we're going to fail micro PVE abruptly. I'm going to unplug the network cable from it. And actually what we're going to do is we're going to migrate it over here, and then we're going to unplug the network cable from this one. And the reason we're going to do it that way is because I don't have the network cable for that one nearby, but this one, the network cable is real close. Okay. So now what we need to do is set up replication. So we're going to go to the data center level. We're going to click on replication. We're going to add, and we're going to add replication for VM100. And the replication target is going to be this one. Schedule is, I thought we had every minute. We can do every minute. Where we don't have a whole lot of, we're only dealing with 1 gigabit of bandwidth, it might be better to do every 2 minutes. But you have to consider how heavy the writes are. If you have something that's just constant writes, may not be a good idea, other than log files. But this is writing very infrequently, so I'm happy to say every minute. And we'll give it a rate limit of 80 megabytes per second. Wait, megabytes per second. We're over 1 gig, yeah. So we'll give it 80%. Okay, and this is going to be enabled. So, boom, there we go. Source and target may not be identical. Missing feature. Okay, so this is why this is happening. I want to set up replication. This already exists on the local disk. So what I'm actually going to have to do is just what I said. I'm going to have to do a migration from this node to this node and select ZFS as the target for it. So let me go back. We're going to go back to storage. And we're going to look at tank 1 over here. And we're going to say what is allowed to happen. We're allowed to have containers and disk images. Good. That's all we want. And then local, we're going to say we're not going to allow disk images. We're not going to allow containers anymore. I'm actually going to move it first before I uncheck those. But we want to not allow those things to exist. So let me go back to the instance that's running that's got Plex on it. I'm going to click migrate. And, oh, can't migrate with local CD DVD. Okay, so we need to go into hardware here. I still have the boot drive in it. So we're going to do not use any media. Boom. Okay, that's good. All right, so we're going to migrate. And then target storage, we're going to switch it from local to tank 1. So cannot migrate from storage type dir to ZFS. No. All right, so in this case, because I had set that one up not the normal way, oh, the way that we fix that problem, if migration fails, then what you have to do is you have to do a backup. So we're going to shut down. We're going to have downtime on this. We're going to issue it a shutdown. So this is it's going to take a couple minutes to shut down. We're going to issue a shutdown. And then we're going to do a backup. So let's go into backups. Backup now. Storage. I guess it has to be local. Mode is snapshot. Mode is stop. We're going to do a stop backup. And that's what we're going to do. Then we're going to restore, but we're going to restore it not to the local. We're going to restore it to ZFS. And this should actually go pretty quick here because it's going to, pretty quickly it's going to hit, it says there's 32 gigabytes there, but pretty quickly it's going to hit where it's all zeros. Nothing's been written to, and then it's just going to go boop. Any other questions while we're waiting for this? So this is good. We basically hit every possible mistake. It's almost like I did this on purpose, except that I didn't. But we have, in this cluster setup, we have hit every possible problem. Another thing that I didn't let you know is that I was testing running Proxmox from a Debian install, because you can install Proxmox on a Debian instance if you have a particular hardware setup that you need to accommodate, and you want to get that set up in a more advanced installer, because the Proxmox installer is pretty streamlined. So I wanted to go through that process and see what it was like, and that led to this other problem. This is not actually an LVM thin. This is operating in directory storage. Okay, so now that we've got this backed up, we click restore storage. We're going to restore it to tank 1. And let's go ahead, override settings, start after restore. Okay, so we back it up from where it was and then restore it to where we want it to be. This will permanently erase. Yes, we're okay with that. And any moment now that should complete. Then we'll be able to start it again and set up a replication job. All right, there we go. So now let's go ahead and start it. We're going to migrate it. We're going to set up replication, and we're going to fail it. So I'm going to let it get running all the way so that I can actually SSH into it so we can have a beat on how this is working. So I'm getting out of the Raspberry Pi that's acting as the quorum device. And I don't remember what this node's IP address is. Let me see. I am running the QEMU agent, so I believe that it will tell me things about the network device. Will it not? Let's see. Options, snapshot. No, okay. It is not showing me the network device information. I can also look this up on my router. Pardonnez-moi while I do that. Okay, IP address is 150. Oh, what? That's not right, is it? Okay, let me see. What's got uptime? What's got the lowest uptime here? Oh, my router's not. Is my router going to see that device? My router's not going to see that device. Okay. Let's see. SSH root at. I think it was 167 was what it ended up being. No. There's 156. No? How about ARP-A? What do we got? What's that? 253. Nothing. Okay, I'm going to actually go into the console. Duh. That makes sense. It'd be really nice if I could see what the IP address is. All right, 192.168.253. Let me just hit up a few times. Oh, nope, not that one. Oh, there it is. Okay, cool. So let's remember that for later. Is this set up on a static IP? Oh, this is actually Ubuntu proper because of course it is. Well, because we're running Plex, and Plex is going to run better on Ubuntu proper. It's got, well, I don't know, probably maybe it would run just fine on Debian. But there may be some things it's taking advantage of in Ubuntu. Ubuntu is the officially supported, so that's what I wanted to use. So I'm just going to look at this real quick and see if I can find... There it is. Oh, for some reason in the router, it's named Ubuntu Server. That's okay. So I'm going to set this one to have a fixed address, and I'm going to put this at 60. So the next time it reboots, it gets... Well, actually, I just keep it at 106 for now. Okay. So... I might change that later. All right. So now we can start to do the good stuff. So now we're going to do first of all, let's do a replication. So we are going to go back to the data center level, And we're going to set up the replication at the data center level because we're letting it know. Oops. Target should be the other node. Yes, the other node is where we're going to target it. And enabled. Okay, cool. So now we've got a replication. We can wait 2 minutes. That should begin to happen. As we look over here, I don't know if it's going to show up in the ZFS stuff or not. It looks like no. Oh, there it is, replication. Okay, so replication is happening right now. Do we have any other detail on this? Nope, that's not what I wanted. Okay. Not sure if it's going to allow us to do this both ways. Okay, no, it's not. All right, that's fine. But point being, now we're going to be able to let's make sure the replication finishes first. All right, so replication took less than a minute, or just slightly over a minute, actually. So now we're going to go ahead and migrate this. Whoops, if I can get this to migrate. And we're going to have it migrate to the other node, and we are going to have it migrate to this storage. Oh, actually, I need to set up high availability. That's what we need to do first here. So I'm going to go back. We're going to set up high availability by going into HA and groups. And what we're going to do is we're going to create a group that has both of these nodes in it. And we could restrict it so it only allows these nodes. When we add a new node, it won't be allowed to go there. And we could add no fail back or not. So this we're going to call prefer micro PVE. So we're going to give this a priority to I actually need to log in and look at my other system real quick. Just one moment. So I can look. Priority is one of those things where it's hard to remember which direction it goes, you know? So I'm going to go look at that real quick. So if we're preferring, okay, whichever one is higher is the one that is preferred. So priority highest wins, not lowest wins. So priority 1 is not the winner. So we could have this one at priority 9,000. No, we can't. We can only do 1,000. Okay, so we set this one at priority 900, this one at priority 100. So it means that what we want is that when this is available, we should be running on this. But if for some reason this becomes unavailable, it can go to some other node and it can do it by priority. There is now an option also to do it by load. So we can specify things at equal priority, and there's a config option that we can say where things are of equal priority, go to the one that has the lowest load. I'm not sure if that's enabled by default. Now we need to add to this group this one. So it's saying how many times should we try to restart it? How many times should we try to relocate it? What state should it be in when it migrates? Should be started. So there we go. Oops. Let's go back. All right, and then let's check the quorum status again real quick. So I think there may be an issue. Okay, we're still seeing the expected votes. Okay, good. And we apparently may have made some change that caused the cluster to increment versions. But we're still seeing that we have 3 votes. So even though in this interface it's not recognizing the correct number of votes, it's okay because the actual thing that matters is recognizing the correct number of votes. All right. So with that, now let's go ahead and this is the one that I have on the desk. So we're going to go ahead, we're going to switch it and make it so that it actually prefers to be elsewhere. So I'm going to create another group. I'm going to call this one prefer MPLX2. Oops. No, I don't want either of these set actually. So this one will be 900 over here, and this one will be 100. Make sure that this is set up right. Yep, that's set up right. So now I'm going to switch this node from one group to the other, and so it's going to cause it to migrate. So, whoops, sorry. I should still be back in data center at HA, high availability. I should be clicked on it at the top level. So we're going to edit this, and we're going to say you're not going to prefer to be on the one that you're on. You're going to prefer to be on the other one instead. Okay. So now, with that change, you can see that it's begun the migration right here. Now, this is a shutdown migration, I believe. I don't think that this is going to live migrate, but let's check and see. It'll be interesting if they've updated this so that it can live migrate. Huh. So when it live migrates, what it does is it copies, well, usually it doesn't have to copy all the disk because the disk is on the network. You're using a cluster file system, but it copies all of the RAM, and then it will keep on copying RAM as things change until it gets to a point where it's ready to do the transfer. So it'll just, do the big chunk of RAM, and then there'll be the little bits that are changing. Wow. Wow. Did that do a live migration? I think that actually did a live migration. I don't... Was I in the middle of having some of these? It either did a live migration or it waited until the last possible moment to shut the other one down. Because that was instant from I was typing here and then hitting delete, and then all of a sudden I got switched over. So if you saw that, let me know. I think that might have been... If that wasn't live, then I don't know what it was. Because that looked like zero downtime to me. That's amazing. Okay, so now we're going to do the thing that I get to do, which is I'm going to go ahead and unplug the network connection here, and we're going to lose connection to that node. And it's going to take a minute. Let me see what the configuration settings are here. So under groups, fencing, use watchdog based fencing. Let me check and see. I don't remember where the watchdog is configured. Okay, PVE HA Watcher. That's what Jippity says. We'll see if that's right. So Etsy, it gave 2 places, PVE HA Manager. Okay, default is soft dog. That's fine. Nope, that was not a real thing. Hallucination. All right. CRM commands, groups, manager status, resources. Well, let's see what's going on. Is it moving it over yet? So it has to wait a certain amount of time to make sure it's not just a network error before it brings it back over. And we may have... Yeah, we're going to give it... So, see, it's assuming that this is still running. It's assuming there's a network communication error, cable got tripped over, whatever. It's not going to do it instantly. I will find out where we set the watchdog time so that we can make it less if we want to. But if you've got a lot of nodes, you actually do want it to wait a couple of minutes, because if it's something that's as simple as a catastrophic power failure where two power cables got tripped over on the instance or whatever it is, it'll move. You're likely to have it boot back up before it would be able to start up all of the instances on the other thing. But I'm hoping that the watchdog will trigger here soon. So if we do PVCM status, we can see that we only have 2 votes now, because one of our nodes is not available, can't be seen. All right. How do I change the HA timeout on Proxmox? Okay, it is in... should be 2 minutes. Okay, cool. Oh, it already happened. There we go. So now, boom. So we had a failure in our cluster, and it recovered gracefully without any input on my end. Also, the advice that I'm seeing in the forums is that, well, what date is this? This is 2022. Okay. The watchdog timeout is hard-coded because reasons. So you do not get to configure the timeout. I thought that there was a way that you could, but you can't. And that's just as well. All right. So now let's say that we take a look at this in HA. Let's go back up to the data center layer. We'll take a look at this in HA. It's prefer MPLX2. So what's going to happen if I plug MPLX2 back in? What will happen is it is going to move back there. That's where this option no failback comes in. If we set no failback, what that means is that when it recovers, it's not going to move back from where it failed from. And the reason that you might want to set that is just for minimal downtime. But we'll go ahead and leave that unset. Now I'm going to plug this node back in, and within a few seconds, it should recognize itself. Okay, so here we are. So now I've plugged the node back in. It may take it a moment to decide to sync up and everything. Okay. So it says, hey, I know I'm online. I don't know if they're online. Now I know they're online. So that little bit of time is the clusters doing some negotiation. It's saying, hey, this is the data that I have. This is the version that I'm at. What version are y'all at? Okay. What data do you have? What data do I have? They get synced up. And then let's see here. I'm going to try this again. Can I be typing on this as it's moving over? Okay. So there were a few seconds of downtime there. You saw that. There was about 3 to 5 seconds of time where it was inaccessible. Now, I'm not sure whether that was a pause or if it was actual downtime, but that's what we're dealing with. So, anyway, This is one of the great benefits of using ZFS and having the ZFS replication. Let's go back up to our replication, and I'm guessing that it would have switched. Let's see. Target went from, yeah, all right, that's as expected. So we can see that before, if you remember, we had the microplex living on micro PVE, and it's unfortunate that Optiplex micro, but then micro, I should probably just call this Plex. That's what I should do. I'm going to rename this for it to not be confusing, because it was cute, and so I named it Microplex. But as cute as it is, that makes it kind of difficult to talk about this. So we're going to rename this to just Plex for the purposes of being able to see it here. Okay, that way we're not confusing Dell Micro Optiplex with Plex running on a Dell Micro Optiplex, which originally was called Microplex. Anyway, okay, so the point that I was getting at is that this, now there's some other things that we can do. We can talk about the networking, the segmentation, etc. But what we have now is we've gone through so many different common errors, just cascading common errors, and fixed all of them, which is great. I actually want to do, I don't want this to be the first lab that we go into, but I think that this should be a lab where we just go through this. This was actually excellent in terms of the cascading failure that happened through so many different systems. And why you never changed the IP address or the host name. Yeah, but this is a production system. So as I said when I started, we can take these two Dell Optiplex micros, we can put them in a 1U rack along with a Raspberry Pi and a Netgear switch. Let me show you the Netgear switch. I've got that out over here. Or is it over there? I moved it somewhere. It's not right there on my desk. Is it right here? Is this it? This is it. Okay, cool. So this is a managed switch. So this is going to work great with your data center connection. This is a business device. It has a 5-year warranty. This is the kind of thing that you can expect reasonably will last 10, 15 years. This is a solid device. Normally I recommend MikroTik, but because we need something that is relatively cheap, and the cheapest one at MikroTik is $100. So we needed something that's cheaper, but that is still business class, that is production ready. And we don't need very much because we're only connecting 3 systems. We do this. And I will also go over how to do redundancy with this. So this costs $40. I have to actually test this in real life, but we should be able to use a couple of shims and actually have redundancy with this. I don't really recommend that. I think if you're at that level where you need that extra 9, you're not doing 2 node clusters anymore. So maybe I won't go over that, but there is a way to create a manual hub, a splitter, put each cable in from each system on both of them, then connect them together. This has anti-loop technology built in, so they'll both receive the signal and then just respond, and then because it's a hub, the natural process that always happens in hubs will happen. And that, if there's a network guru making a comment here, he's going to tell you don't do that. I'm just saying, I believe there's a way to configure it that it will have failover, but yeah, at that point, just have a third node and get a second U for a real network switch. So obviously we got to condense this material down. We got to streamline the process for the happy path, which is what I wanted to focus on. But because I was playing around, we ended up on the not happy path. Other than that, I'm super happy that there was no downtime there. That was crazy. I'm going to try that one more time, and I'm going to actually be pinging it while this is going on. So okay, shared connection did close. Okay, so it did actually have real downtime. There was actual real downtime. It just was very, very little, because otherwise the connection wouldn't have closed. So we're just going to keep on running ping on that. I'm going to go switch this over one last time so that we can see it in action. That's just, yeah, ZFS is great. It's great for this type of replication because the snapshotting, as you saw, made it so seamless to go from one to the other and then just, and it's booting out of RAM, by the way. That's the other thing I didn't mention. When you're in ZFS, your data that has just been copied or transferred is in RAM. So let me go up to the summary here and let's see if we can take a look at our RAM. Okay, so you'll notice that across the cluster, we're using 9 gigs of RAM. What are we using that 9 gigs of RAM on? A lot of it is actually being used on ZFS. So if we go over here, we take a look at the summary of this. This is one of the downsides of ZFS. So look how much memory is being used. That's not being used. Well, actually, a lot of it is being used on the, let's see, on this one. Let's see, what is his memory usage at right now? Okay. So that's, yeah, a lot of that's going to be ZFS memory usage. And then same thing, if we go over here and we look at memory usage, this one's going to be higher because it's got dedicated memory from the VM. And this one's got a lot more memory, so the graph doesn't go as high. But you can see here, yeah, so a lot of the baseline here is ZFS. But they did tune it. Proxmox updated it, so it tuned it, so it uses, the minimum is much lower, because when you're starting out with small disks like these, you don't need ZFS taking up 8 gigs. But my point was, ZFS works really, really well in terms of being able to transfer files, and then that VM was stored in memory when it was booting. That's why it booted so quickly. Or the majority of it that was needed was still in RAM, because it's in ZFS, and ZFS is RAM first and then file system second. So one more time, we're going to data center. We're going to go into HA. We're going to select this dude here, and we're going to go from prefer MPlex 2 to prefer micro PVE. And then we are going to let him do his thing. So we should see, oh, did I not click? Oh, there it goes. All right. So it's in transit. Let's see how much downtime we see. How many pings are we going to miss? Boop, 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 boop. All right, so boom. That was our downtime, folks. 4 pings. So this is a production system. This is something that you can host for yourself and have customers on. That's set up right there. Now, if we do CephFS, we get some other benefits. We actually will have fewer pings down. In fact, I think, well, the way that the request timeouts work for this, we will probably still see a timeout, but when you're doing CephFS and you're doing a migration, you're not going to have any actual downtime. It's just going to pause the TCP session, then you're going to continue. Okay. So again, that was quite a bit more than I was expecting to cover here. Let me go over my notes and see if there was anything else. Obviously, got to get this streamlined. I did want to mention the hardware that we're using here, just in case you're interested. So let me bring this up. I'm going to copy the links in. Well, let me just copy the link here. There's in this document, there's a section down at the bottom that's called Production Ready Cluster. I'm going to do a segment that's just on hardware, but let's take a look at this so you can kind of get a feel for it. This is really great bang for buck when you're looking at getting your setup here. So this, oh, it looks like I got the, oh, no, that's the right link. That's the right link. Okay, so this is one of my Dell Optiplexes. Here is my other Dell Optiplex. So look, this one, 120 bucks. This one, 250 bucks. This one, 16 gigs of RAM. Quad core, 8-thread processor. So think about that in terms of, and this is real processor, right? So this isn't a vCPU where every vCPU is essentially equivalent to about 500 megahertz, really, because it's a vCPU is 1 gigahertz thread, but a thread is counted. So CPU cores are counted by their hyperthreading. So if you have 12 cores, then you have 24 CPUs that are represented, which means that you have 48 vCPUs, and then in cloud providers, those are going to be split up by gigahertz. So if you've got the baseline is 2 gigahertz, so now you're up to 48. So 48 vCPUs off of 12. So if you look at this, this is quad core. It says up to 3 gigahertz, but it runs at 2.5. So take that. So quad core, hyper threaded, that's 8 vCPUs times, let's just say times 2, because there's a little bit of overhead, whatever, 2 gigahertz. So that's 16 vCPUs. So if you were paying for 16 vCPUs, that's what this is, and 16 gigs of RAM. This other one is a little faster. So this one is not hyper threaded, so it's a little different. This one has 6 actual cores rather than 4 plus 4 on hyperthreading. So this is actually better performance, but it's only going to be listed as 6 cores. I'm not sure how to do the vCPU conversion on that. But again, 2.2 gigahertz is the base here, 32 gigs of RAM. So just think about that. Within a matter of something in the realm of 6 months to a year, this is absolutely paid for itself. The setup with these. You add in that switch, because what are you paying per month with whatever you're using as a small business? You run a dev environment, a staging environment, 2 databases, you're up to $400-500, right? So that for the essentially, depending on what you're doing, this thing pays for itself in a month. And then, like I was mentioning before, I am in the pipeline for becoming a Proxmox authorized reseller. So if you're going to run this in your business, obviously you ought to pay for the enterprise license to get the subscription. The no subscription repos are stable. You're not going to have a bad time with them. But if you're running this in production, let the beta testers that aren't paying be the beta testers. Don't be part of the beta tester group. And it's not like a beta tester group, like an alpha tester group. I have run the no PVE subscription. I have had no problems with it. But as a business, you want to make sure that the things that you love, stay available. So down in support. Oh, where was it? Is it under this one? Under subscription. There we go. So you can see you can get a subscription. So hit me up if you're interested in that. You can comment in the channel. You can reach out to me on Discord, whatever. Oh yeah, I was going to check my notes for a couple of other things. So we had the Netgear switch. Did I paste? Yeah, I did paste that link. We've got the Netgear switch. Let's bring that up again. This is a business class switch, 5-year warranty, managed. We're not going to go into that tonight, obviously, because we're wrapping up here. But this will be able to handle the VLAN so that when you're plugged into your data center, there's a little bit of configuration you need to do. I'll show you how to do it. But your data center is going to have 3 options, which is tagged, untagged, or default tag on your network interface. Untagged just means a normal internet connection or normal Ethernet connection. It's not on the other end because they have firewalls in place that use tagging, VLAN tagging, to separate your network from other networks to keep everybody safe and happy. But it presents it to you as though, you just use it with any normal switch. You don't need to worry about it. Then they have Tagged means that you have to explicitly pick a VLAN to join. They'll tell you, okay, you have this Ethernet cable, you're on VLAN 10 for your outbound connection. And so then you set up VLAN 10 as your outbound connection in the switch, and you get your it's a pain in the butt. Like, this is something we're gonna do it the hard way, but it's a pain in the butt to add IP addresses to your cluster to get things right. It's much simpler to just, in many cases, to reinstall, so that when you set up the cluster, you want all your network interfaces to already be defined. Ideally, I'm going to show you how to do it so that if you're growing like what we're demonstrating here, you can go through the process without having to reinstall, but it's not officially supported. And the reinstall is, if you don't hit any snags and you do it right on the first try, it's faster than reinstalling. If you hit any snags at all, you would have better been to just down that node from the cluster and reinstall. Anyway, so yeah, so this is completely pro stuff. $40. Compare that to, you're going to pay 15, 25, well, 15 for an unmanaged switch, 25 for a managed switch that isn't a Netgear ProSafe business. But that, come on. And that just makes a ton of sense. Then I really like Monoprice and Unify for the network cables because they're just so sleek and simple, and they're really cheap. So, and then Monoprices are similar. I'll show you what those look like. Let me just grab that real quick. But I don't. It's not that I have any special love for them. They're just they look nice. They're easy to work with. They're not bulky and in the way. And Monoprice has different color options you can choose. So if you'd like PoE, make it red or whatever. Right now they're out of the normal patch cables, the 6-inch and 1 foot in this style, but there's another style that they have. I'm not going to go into it. And then the last thing, of course, was, yeah, I'd appreciate it if you hit me up if you want to get the enterprise license. But if you just want to go ahead and grab it, you can get it. Just search Proxmox enterprise license. So this is about $125. So that's community. That doesn't come with any support. If you want to get support, then you go up significantly. And then, the more primo support you want. Obviously, if you're mid-sized business, this is the best deal. It's the best bang for buck if you are a mid-size and growing. But for what we're talking about here, this is the right choice probably. Or this. If you go through me for support, I'm going to push you into this because I, as an authorized reseller, will want to be able. First of all, I would be the first line of defense to help you. Most of the time, I'm going to be able to help you. But if I can't help you, then I want the ability to be able to reach out and say, hey, we're having a unique problem I haven't dealt with before. This is the customer, and then be able to use those customer requests. I mean, essentially, what you'd end up having to pay me would be the upgrade cost, right? Like if we had a more complicated situation versus, but I mean, and you could just do it at that time too. I mean, that's fine. But if I have to consult and spend a few hours, it's not just one of the simple problems I can rattle off. Okay, here's the answer. Anyway, so there's that. And then that's what all I had to say about hardware. I just wanted to see what this hardware sets up, the 1U rack. And I pointed out that the rack you can buy, it's $200 if you want the actual rack. Otherwise you just get a tray. You can put it in a tray, just rack mount tray, get one that's 16 inches. Let's see. How many inches is this? It says 4 and 19 inch, 16 inch deep. Yeah, right here. So you could get this, or you could get 1U, that's fine. Get the 16-inch 1U. I would never get anything from Pile. I've never enjoyed my experience with them. How could you possibly get metal wrong? It's got to be fine, right? I'm not going to risk it. Anyway, so there's that. And then, yeah, so you finalize your node name, finalize your IP, only create instances on the leader, meaning that this was empty. This one didn't have any instances on it. When we go to join the cluster, you cannot have instances on something when you're having it join the cluster. You have to shut everything down. You can manually back it up and then restore it. That is possible to do, but it's a pain in the butt. I don't know why you would do it unless you're just, you're goofing around and you're like, oh, I'm going to start something up on this too. And then you don't realize you're not supposed to do that. And then, okay. You want to figure out what your uptime is supposed to be. You want to figure out how many nines you want. And I think as you saw here, you get pretty daggone good nines on your service. We saw a skip of 4 seconds. And like I said, if that was a TCP connection, well, it would be downtime because those connections would error out, if I'm not mistaken. I have to try it. I have to actually put up an HTTP service and do a multi-gigabyte download while it's switching over and see. But I'm pretty sure, it'd be awesome if I'm wrong, but I'm pretty sure that rebooted and restarted. It's just because it was doing it in RAM. It did it hyper fast. Okay, so yeah, planning storage. If you're going to do a cluster, you either want shared storage or replicated storage. I don't like any of the shared storage options for a 2-node cluster. So we got to do replicated. We got to use ZFS. We wiped out the partition. We can't, as you saw, we can use a partition. You're supposed to use a whole disk because the way ZFS is optimized, it wants control over the disk. It's not going to work right on a partition. It's not going to work the way it's intended on a partition. It's not going to work correctly if it's over RAID. If you're using RAID, it needs to be pass-through mode. We did the Quorum device. We didn't go through how we set up the Quorum device. Since I'm recommending Raspberry Pi, I can show how to do that. It's the same if you use Libre Computer or NanoPi, because Raspberry Pis are really expensive right now on Amazon. If you go on eBay, you can get, if it's a Raspberry Pi 2 with wireless, the ones that have the wireless chip are actually Raspberry Pi 3s. So they are printed Raspberry Pi 2. They're actually Raspberry Pi 3s. They still have, the Raspberry Pi 2s because they have the same connectors as the Raspberry Pi 2. But they are retrofitted Raspberry Pi 3s. So Raspberry Pi 2, it can't be a Raspberry Pi 2 base. It has to be the Raspberry Pi 2 that's actually a Raspberry Pi 3 because you need it to be ARM64. You don't want to be dealing with the old ARM stuff. You could risk it. I would not risk it. But yeah, look. So you get a Model 3 for $30 on eBay, then you get a case on Amazon for $6. To me, that makes sense. The way they're selling on Amazon right now doesn't make any sense to me. If you wanted to get a Pi 4, whatever, but just the cheapest you can get, because all you're using it for is a voting node that says, hey, the network's up, the problem's not us, it's you. That's what the Quorum node does. It says we're good. And then, yeah, so that's it. We went over everything. That was very realistic. That was very realistic for what you might experience as a beginner setting this up for your business. We'll streamline this. We'll get a better video for it. But yeah. And then this one, again, I think the QEMU agent just isn't running properly because it's not actually using all of that RAM. If we go in there and we take a look right now. Sorry, I switched topics. I was just clicking around. Okay, we're going to go on 106 again, right? Okay, so if we run htop, okay, apt get install -y htop. Let's oh. Okay, so if we run htop, you can see that the memory that it's using is only so much. The overhead might come from the ballooning device or something. And we have QEMU agent installed, right? History, grep, QEMU. Yeah, we started and enabled the guest agent. So I'm not sure. And I did a guest agent ping. So I don't know why it's not reporting the right amount of RAM used. I don't know. I'm not using a cloud image on here. I installed from the ISO. Generally, we want to use cloud images because they are configured. They already have the QEMU agent. Everything's already configured correctly in a cloud image to be running in this way inside of virtualization. All the virtualization drivers are in there. Maybe I don't have the virtualization drivers installed because I thought it would detect them automatically from the ISO, but whatever. Anyway, so that's all of that. I hope that you find that helpful. If you did, like, sub, follow if you want to. I'm going to be doing, like I said, probably about one of these a week. It's going to be in this format. Some of them are going to be a little better polished, some of them a little less. I actually spent quite a bit of time making sure that the documentation was correct and up to date. But that one step I put out of order because I thought, I was going to do it offline. I was going to do it just moments before hitting the record button. And I thought, no, I want to show how to do this. Just in case, because it is something that you set something up and you're like, oh, now I actually want to get this thing going. Let me go change that IP address because I just got that via, I just pulled that number out of my hat, but I want things to be organized. So anyway, thanks for tuning in. Like, sub, follow if you want to. Catch you later. And yeah, contact information, the Discord, you've got it right there. Hit me up on X_Beyond Code. Adios.